So in this particular session, we are going to specifically focus on the ionic bonds. So ionic bonds are formed between a metal and a non-metal. So metal and a non-metal, when they combine together, they form the ionic bond. The reason is that the metal are electropositive in nature and the non-metals are electronegative in nature. So electropositive, I have already explained you what do I mean by electropositive. Electropositive means they have a tendency to form a positive ion, and the positive ions are basically known as cations. And the non-metals, they have a tendency to, they are electronegative in nature. They have a tendency to acquire an electron. So they are basically your anions. So what is happening here? There is a transference of electron taking place from metal to non-metal. And this transference of electron is making them bind together. It's binding together. So this force, which is binding the metal cation and a non-metal anion, because of the transference of electron, this is an electrostatic force, which is basically known as my ionic bonding. So what is ionic bonding? Ionic bonding is an electrostatic force between the two different ions. Okay, so we can define an ionic bonding as, we can define an ionic bonding as an electrostatic force. I'm just writing it down. So we'll write it down. It's ionic bonding. Ionic bonding is an electrostatic force of attraction, between two type of ions, formed due to transference of electrons. So due to the transference of electron, these ions are being formed, and these ions are basically what? They are your positively charged ion and your negatively charged ion. So they are basically your cations and they are your anions. So these cations and anions are oppositely charged, so they will be an electrostatic force of attraction, which is basically called my ionic bonding. So let's get back again onto the slide and let's do the property. The covalent bonding we'll do in the next session. So let's move ahead. When we talk about the neutral atom, when we talk about the neutral atom, if it is a metal or if it is a non-metal, the non-metal basically kya hoga? The non-metal atom is going to accept an electron and will be forming an anion. The metal atom is going to donate the electron to form a cation. But why this donation and acceptance is taking place? This acceptance and donation of electron taking place because they want to attain the nearest noble gas configuration that we already know from O levels, right? Moving ahead. Now, this is how the ions form. Now, this aluminium is an example. It's a metal. It has 3 valence electron in its last shell, and we know it has a configuration of 2, 8, 3. So 3 electrons it has in the last shell. Now, it will shed these 3 electrons and it'll acquire the configuration of 2, 8. And because it will be losing 3 electrons, it will be having 3 electrons more. That means the protons are still 13 in number, but the electrons have been shed and they are 10. They are as the nearest noble gas. ठीक है, nearest noble gas जितने electrons हैं, तो अब यहाँ पर इसके पास 3 protons ज़्यादा हैं, so it will be having a 3 positive charge. So aluminium as an atom is going to lose its 3 electron to form 3 positive ions. So it will be donating. Okay, moving ahead. Now they will be, here is an oxygen. Now in the case of oxygen, what is happening? The conjugation is 2, 6. That means it is deficient. It is lacking 2 electrons. Nearest noble gas से इसके पास 2 electrons less हैं, तो ये क्या करेगा? It will be accepting 2 electrons. So these ones are the accepted electrons. तो इसके पास जितने number of protons हैं, the number of protons remain the same. The protons are basically how many? 8 in number, but the acquired electrons plus 8 makes it 10. See the configuration. So that is why, because electrons are more than the protons, so it is going to acquire a 2 negative charge, and this is what happening. Oxygen is going to acquire 2 electrons and its number of electron will be more, hence it will be acquiring a 2 negative charge. Okay, so this is how the cation and anion they are formed. So so what is happening? The metal, we have a dot and cross diagram here. We have a metal sodium and we have a non-metal chlorine here. So what is happening? The metal has one electron extra. So that one extra electron will be transferred to the chlorine in order to complete its octet. So it is having 7 of its own. So one extra will be passed on to the sodium. Now sodium will be having a configuration of 2,8 and will be acquiring a charge positive, whereas the chlorine will also have the configuration of 2,8 after having the acquired electron. ये acquired electron है उसके पास और उसके पास negative. अब क्या है? What is happening here? Now there is a strong force between these. There is a strong electrostatic force between a cation and between an anion. Now because they are oppositely charged, there's a force of attraction between them. और ये cation और anion क्यों बने? Because of the transference of electron, and this kind of a bond between a cation and an anion is known as ionic bond. So this is how you define the ionic bond. तो ionic bond की examiner हमसे definition पूछता है. He asks us to draw the dot and cross diagram like this, how the metal converts into cation, how the non-metal converts into cation. तो अगर वो किसी भी compound का देगा तो you should be knowing how to draw the dot and cross diagram. That's the second one. Or they give you a dot and cross and they can ask you in the form of an MCQ. And the third thing which they ask is about the properties. So we are just moving towards the properties. Now, let me tell you that the ionic compound also they exist in the lattice form. ठीक है, ionic compound भी अपने lattice form में exist करते हैं. तो ionic compound exists in the lattice form. So this is a structure for the lattice of the sodium chloride. Now where one chloride is surrounded by 6 sodium, and in turn one sodium will be surrounded by 6 chloride. So it's a 3D structure. Okay, for the sodium chloride specifically. There are other type of lattices, but we don't have to do it at the A levels. Right now, we are just doing this simple structure of sodium chloride, which is hexagonal 3D structure. Now, because they all exist, the ionic compound, they exist in the lattice form where there are multiple ions. So in order to break down these numerous bonds, they have to give a large amount of energy. तो ये lattice form में exist करता है, तो basically जितने भी ionic compounds हैं वो solid state में exist करेंगे. तो अगर आपको इनको melt करना है या फिर आप इनको boil करेंगे तो you have to break all these bonds. So the first property is, because they exist in the lattice form, these ionic compound will be having extremely high melting and boiling point. And as I've already told you before that के metallic lattices जो होते हैं वो जो है they are the strongest one. तो metals का जो melting and boiling point होता है वो काफी high होता है. उसके बाद सेकेंड नंबर पे स्ट्रेंथ वाइज आपके आयनिक कंपाउंड्स आते हैं. ठीक है, तो इनका भी हाई मेल्टिंग एंड बॉइलिंग पॉइंट होता है. दैट्स अ फर्स्ट प्रॉपर्टी. इसके अलावा नाउ व्हेन दीज लैटिसेस दे विल ब्रेक, why the electricity will be conducted? The electricity is conducted because of the mobile particles. Now those mobile particles, they can be either in the form of ions. You can have the mobile ions, or you can have the mobile electrons or the delocalized electrons. So you have the delocalized electrons in the metals, right? They keep on moving from one place to another. But when you talk about the lattice structure of the ionic compound, these ions are fixed or fused. ठीक है, ये सारे फिक्स होते हैं फिक्स स्टेट में. जब मेटल अपने सॉलिड फॉर्म में होता है या मेटल अपने लैटिस फॉर्म में होता है, तो हम सेकेंड प्रॉपर्टी जो है इसकी हम कहते हैं, पहला तो हाई मेल्टिंग एंड बॉइलिंग पॉइंट हो गया. दूसरी प्रॉपर्टी दैट दे विल बी कंडक्टिंग इलेक्ट्रिसिटी. So conduction of electricity is only when these particles are mobile. ठीक है, conducting electricity when the particles will be mobile. So that means in the solid form, none of the ionic compound can conduct electricity. तो conduction सिर्फ होगी जब आपके पास mobile ions होंगे. So they will be conducting electricity in the aqueous form और इन द मोल्टेन फॉर्म। तो जब आप इन आयनिक कंपाउंड्स को मेल्ट करेंगे या आप इनको डिसॉल्व करेंगे, सिर्फ उस स्टेट में इनके पास जो होंगे मोबाइल इलेक्ट्रॉन्स होंगे। जब मोबाइल इलेक्ट्रॉन्स होंगे तो फिर वो कंडक्ट कर सकेंगे। तो दिस इज द सेकंड प्रॉपर्टी, राइट? The first was high melting and boiling point. The second is conducting electricity in the aqueous or molten form. The third property, they are soluble in water. Now, why soluble in water? They're soluble in water because they are charged particles. Because in the what do you call it? The ionic compound, they have the charged particles, right? When you talk about the water is again a polar compound with the partial positive end and with the partial negative end. Water जो है वो आपका पोलर कंपाउंड, पोलर कोवलेंट कंपाउंड है, जिसके पास पार्शियल पॉजिटिव चार्ज टुवर्ड्स हाइड्रोजन है और पार्शियल नेगेटिव चार्ज टुवर्ड्स ऑक्सीजन है। तो यहाँ पर क्या होता है कि ये जो है आपका सोडियम जो है वो ऑक्सीजन एन के साथ कनेक्ट हो जाएगा, जो कि आपका पार्शियली नेगेटिव है, और हाइड्रोजन एंड्स विल बी अवे फ्रॉम द ऑक्सीजन एंड, ठीक है, फ्रॉम अवे फ्रॉम द सोडियम एंड। और यहाँ पर इन दोनों के बीच में, बिकॉज दे आर अगेन ऑपोजिटली चार्ज, दे विल बी अ बॉन्ड फॉर्म बिटवीन देम। यहाँ पर इन दोनों के बीच में लिंक फॉर्म हो जाएगा, जिसकी वजह से ये बॉन्ड जो है ये वीकन अप हो जाएगा, ये बॉन्ड वीकन अप हो जाएगा, और सोडियम विल गेट डिसॉल्व्ड इन द वाटर। सिमिलरली व्हाट विल हैपन, द वाटर का जो हाइड्रोजन एंड है, जो वाटर का जो हाइड्रोजन एंड है, जो पार्शली पॉजिटिव एंड ऑफ द वाटर है, ठीक है, दिस इज ऑक्सीजन विच इज पार्शली नेगेटिव and this is another partial positive end of water. This will get associated with, this will get connected with or bonded with the negative end of the lattice of the ionic compound, और जिसकी वजह से ये वाले bonds और ये वाले bonds जो है वो वीक हो जाएंगे, और इसकी वजह इसके साथ क्या होगा, जो क्लोराइड होगा वो डिसॉल्व हो जाएगा। तो स्लोली एंड ग्रेजुअली जब आप कोई क्रिस्टल या कोई लैटिस आप वाटर के अंदर डालते हैं, तो इस तरह से वो पूरा का पूरा लैटिस, उसके कैटायंस और उसके एनायंस ब्रेक डाउन हो जाते हैं, एंड देन वी से दैट द आयनिक कंपाउंड गेट डिसॉल्व्ड in water, it get dissolved in water. So all the ionic compounds are water soluble. That's the third property. The third property is that the ionic compounds are soluble in water. They are soluble in water. Is all we have studied till now. Definition हमने कर ली, हमने dot and cross कर लिया, ठीक है, और हमने properties कर ली, and we know the reasons for these properties. Ionic compound conduct electricity because they are free mobile in the molten aqueous, they exist in the lattice form. They have a high melting and boiling point because they exist in lattice and remain the solid form. They're solid in water, we have studied, because water is a polar and it attracts the different oppositely charged particle, break the bond, ionic bond, hence they become water soluble. Lastly, they have a high melting and boiling point, so they exist in the solid state in the lattice structure. Then there is one more thing which comes here. That means that they ask you that when you talk about the melting point or when you talk about the boiling point, they both are these are the examples of your ionic compounds only. One is your sodium chloride, another one is your magnesium chloride. So जब आप सोडियम क्लोराइड लैटिस की बात करते हैं और मैग्नीशियम क्लोराइड लैटिस की बात करते हैं, तो सोडियम क्लोराइड का लैटिस या सोडियम क्लोराइड कंपाउंड जो है, दैट हैज अ लो मेल्टिंग एंड बॉइलिंग पॉइंट, that has a low melting and boiling point as compared to magnesium chloride. Now, any guesses, any reason why is it so? Why this has a high melting and boiling point in comparison to the sodium chloride? Any guesses? What is happening when NaCl is forming? There is only the transference of one electron taking place. ठीक है, तो वन इलेक्ट्रॉन ट्रांसफर हो रहा है, और जब मैग्नीशियम क्लोराइड हो रहा है, देयर इज अ टू ट्रांसफरेंस ऑफ टू इलेक्ट्रॉन. नाउ व्हेन देयर इज अ ट्रांसफरेंस ऑफ वन इलेक्ट्रॉन, तो इनके बीच का जो इलेक्ट्रोस्टैटिक फोर्स होगा बिटवीन द Na ions and between the chloride ions will be less stronger than the magnesium and the 2 chloride, because there the transference of electron is of 2 electrons, and this is going to be a more stronger electrostatic force. So depending on the electrostatic force, the type of this electrostatic force is between cation and this is also between cation, but this is a stronger one. The reason is because here the two electrons are being transferred. यहाँ पर दो electrons transfer हो रहे हैं और यहाँ पर one electron has been transferred. So according to that, आपका electrostatic force of attraction second scenario में magnesium chloride के scenario में strong होगा. Because this is going to be stronger, the electrostatic force of attraction, the electrostatic force of attraction will be stronger as compared to sodium chloride. That is why it's going to have a high melting and boiling point in comparison to sodium chloride's low melting and boiling point. So with that, we have finished ionic compounds. Let's move on to the covalent bonds.